Good day, everyone. In today's lecture, we will discuss software verification and validation. The objectives of this lecture are to explain software verification and validation, to discuss functional and non-functional software requirements, to discuss the various methods of software verification, and to explain software validation and discuss the method of software validation. So let's start. Verification and validation is the process of checking that a software system meets specification and requirements so that it fulfills its intended purpose. Before a software is developed, there needs to be some specifications that the software should be able to meet. And considering those specifications are very, very important. Those specifications will help us to know if the software is of the right quality and standard or not. So verification and validation, they are similar, but they are not exactly the same. The difference is that in verification, we are asking the question, are we building the product right? Once more, in verification, we tend to ask the question, are we building the product right? While in validation, we are trying to ask the question, are we building the right product? Let's look more at verification. Verification in general is a demonstration of consistency, completeness, and correctness of the software at each stage and between each stage of the development cycle. In the development cycle of the software, there are various stages of the software development cycle. So, in verification, we are trying to look at the consistency and the completeness and correctness of the software at each of the various stages of software development. During verification, the system or component is evaluated to determine whether the product requirements are satisfied. So in general, software verification determines whether the software built meets the expected requirements without actually executing the code. So in verification, you want to see whether the software actually meets the requirements. In software verification, we review the documents and perform a review of the code to find faults in the system in the early stages of development. Let's look at some of the main software requirements. Software requirements are broadly categorized into two: functional and non-functional requirements. Once more, the two main types of software requirements are functional and non-functional requirements. Functional requirements are related to the functional aspects of the software. That is, what are those things that are required for the software to function effectively? Those specific things that are required for the software to function effectively are the requirements that must be met, considered as the functional requirements. They define the functions and functionality within and from the software systems. Typical examples of software requirements include: 1. The search option given to users to search from various invoices. That is a typical example. Another example is Users should be able to mail any reports to management. Sending an email in that context is a functional requirement. Under requirements, user can be divided into groups, and groups can be given separate rights. If you have a software in which users need to be divided into various groups, and the groups need to be given specific rights or privileges. So that aspect of the rights and privileges of those groups are functional requirements for that software. Then the software should comply with business rules and administrative functions. The non-functional requirements are not related to functional aspects of the software. They are implicit or expected characteristics of the software, which users make assumption of. So non-functional requirements, as we said, they are not related directly to a function of the software, but there are certain features that could be of benefit in the software. Now, examples of non-functional requirements include security, login, storage, configuration, performance, cost, interoperability, flexibility, disaster recovery, and accessibility. Let's look at program verification. Testing is the traditional technique that is used to determine and assure the quality of products. So, computer programs need to be verified to ensure that they are able to meet design requirements. So, the most commonly used verification methods are peer reviews, walkthroughs, inspections. In peer reviews, other developers review the documents to find faults in the system. So during the period of peer review, the software requirements verification document is reviewed in detail. Those reviewers take time to review the details of that software requirement verification document to ensure that the software that is developed is able to meet both the functional and the non-functional requirements. Usually it's an informal activity and provides the best results only if the reviewer has the following: 1, domain knowledge, proper involvement, and good programming skills. So a reviewer that is involved in peer review should be able to have a good knowledge of the domain, that is the area of the software, specific area of the software, and is involved has a good hands-on experience in computer programming. Then next is walkthroughs. In walkthroughs, the author prepares for the meeting and presents the documents to a small group. So in this case, when we are talking about walkthroughs, the author has prepared the documents and he explains the various sections to members in a small group. Usually distributes the document to the team and introduces the material to familiarize people with the document. All the participants can usually ask questions. They are free to ask questions and discuss the product's functionality, and then write the faults and defects in a report. So once the developer of the software has done his presentation walking through the main features of the software to the panel, the reviewers make their reports. At the end of the meeting, the author writes a detailed report and the faults identified are stated. Then you have inspection. During inspection, a group of trained professionals review the code and the design. So trained professionals that are experts are involved in the review of the code and the design. That is what happens during inspection. The members of the review group are not on the development team. They are usually not on the development team. Then the next is certification. Software certification is a formal process that ensures that a software product meets specific standards and requirements. Certification is acceptance of software by an authorized agent. When a software is certified, it means that an authorized agent has examined that software and they have given the necessary approval for that software to be used. And usually they are, after they have done proper validation, their agent or officer has done proper validation of the software, and they have found that the software is of the right quality. So usually the certification process involves rigorous testing, evaluation, and validation to verify that the software performs as intended and adheres to industry standards. So before certification is given to a particular software, the reviewers have to certify that that software meets the required standards, industry standards, before it can get the required certification. So the overall goal of certification is to provide the assurance that the software meets the basic requirements and is of the right quality, it's reliable, it's secure, and that is very, very important. Because once a software is certified, the customers will have that assurance that they are paying for something of the right quality. Some common software quality standards, usually the software quality standards are a set of guidelines and criteria that are designed to ensure the quality of software products. These standards usually cover various aspects of software development, including processes, product quality, and evaluation techniques. Some of the common quality standards are your ISO 25010 that was released in 2011. It's the systems and software quality requirements and evaluation. ISO 12207, which is the ISO standards that focused on software lifecycle processes. ISO 27001, which developed in 2013, that is specialized in information security management systems. ISO 9003, ISO 9003 that was launched in 2018 provides the guideline for ISO 9000 computer software certification. Then software validation is the determination of the correctness of the final program. So validation is the determination of the correctness of the final program or the final software produced from a development project. Validation is usually accomplished by verifying each stage of the software development cycle. Software validation can be performed by internal and external validators. In internal software validation, this focuses on meeting the requirement specification prescribed by the stakeholders. So the requirements specification that is prescribed by the stakeholders has to be met. While in external validation happens when it's performed by asking the stakeholders software to meet. In external validation, you are trying to ensure that it meets the specification of certification authority, the authority that usually certifies software. Some of the things that happen, one is code verification. Verification for completeness of the code, correctness and consistency, code metric analysis, and coding standards compliance verification. Then under validation, we have identification of unstable components. Validation focuses on error handling, complementary validation regarding one performed by the development team, compliance with software and system requirements, black box testing and white box testing, and experience-based techniques.